Today's lesson is 6-4, elimination using multiplication. It's a slight expansion on the other day when we just eliminated. The difference is that was set up for you. Today it's not. Okay, so today you have to make it so that it can eliminate. All right. It's one of your major topics. If I was going to pinpoint a few things from Algebra 1 that you definitely need going forward, it's one of them. All right, how to set up a system and eliminate using multiplication. All right. So here we go. No warm-up. Great. Just out of the gate. Here we go. Your first system is 5x plus 6y equals -8. 2x plus 3y equals -5. Okay, now remember from the other day how elimination worked when it was with addition and subtraction. The book and myself were all very nice to you. We gave you problems that you could just add the terms together and they fall out, and everything was hunky-dory. Not anymore. All right. If you notice, you have 5x and 2x. You have 6y and 3y. Nothing's going to cancel when you add them together. So you have to do some operations to make them cancel. Okay? Now, if you look, and you look closely, and this will come with practice and experience, there should be a clear-cut winner as to what you should do. And I'm going to tell you right now, you should eliminate your y's. Okay? Why am I wise? Isaiah.
Because 3y could go to 6y, so you just times the whole equation by 2.
Okay, I like 99% of what you said. He noticed that 3y and 6y was on his y's, and he knew that 3 times 2 would give you 6. Okay, so 5x plus 6y equals -8. Alrighty, and I'm going to multiply. I don't know what I just did there. Okay, and I'm going to take that second equation. I'm going to take a red pen here, and I'm going to put a 2 here. Alright, now, remember what I said. I like 99% of what he said. What's the 1% I don't like?
It's not negative.
It's not negative. Why do I want it to be negative, Mr.?
So they can cancel out.
So they can cancel out when you what?
Add them together.
Perfect. They cancel when you add. Okay. I'd much rather see you guys change the sign here when you multiply and then add them up. Alright? So now take that equation, that 2x plus 3y equals -5, and multiply everything by -2, which gives you -4x minus 6y equals 10. Okay. Hopefully, it's kind of obvious where the mistakes happen here. It's with your signs. Okay. So you have to be careful with your negative signs. When you multiply, you change the signs on everything. All right. Any questions on that? Okay. After you do that, it's set up just like the other day. You just add them all together. So 5x plus -4x gives you x. 6y plus -6y gives you 0. -8 plus 10 gives you
This dude's
2.
my bad.
Okay? The lack of hair is messing with his brain. It's all right. Me too, buddy. Hey, notice we're like all samesies now. Look at us. All right?
You guys a different laugh note too. Just hit.
Once you have that 2, where do you go with it? Back in the equation. Which one, Mr. Jansen?
It doesn't matter.
It doesn't matter, but here's my advice. Okay? Shh. It doesn't matter. Just make sure you go back to one of the original 2. All right? I would feel much more comfortable if you went back to the original 2. Even the one you change. Okay? If you go down here, that's no big deal. Don't mess with these 2. All right? Mostly because if you made a mistake, when you plug it in here, you may not find it. If you made a mistake and you plug it in here, chances are that second number, if the first number is nice, that second number won't be. So we'll go back to one of your originals. I'm going to go to my bottom one. So 2 times 2 plus 3y equals -5. 2 times 2 gives you 4. Subtract 4, you get negative 9 over here. Divide by 3, y equals negative 3. So your answer is 2. Negative 3, still written in order pair. Alright, so we got 6x minus 2y equals 10. 3x minus 7y equals negative 19. Take the bottom one, hopefully we did, and multiply it by negative 2. Okay, it won't always be negative 2. Alright, don't think it's always going to be multiplied by negative 2, and that's it. And, okay, it can be anything. Alright, so 6x minus 2y equals 10. Negative 6x plus 14y equals 38. Alright, now you go through, add up your terms. So 6x plus negative 6x gives you 0. Negative 2y plus 14y gives you 12y. 10 plus 38 gives you 48. Everybody good? Divide by 12. So y equals 4. Take 4 back into one of your originals. I'm going to go top of this time. So 6x minus 2 times 4 equals 10. Be careful also, whichever you solve for first, make sure you substitute it in for that one. Alright, i.e., last time we eliminated our y's and we had x first, so we plugged that number into x. This time we eliminated our x's, solved for y first, so make sure you plug 4 in for y. I've seen people just plug it into x no matter what, plug it into y no matter what. It's whichever one you solve for, okay? Don't forget about that. So you get 6x minus 8 equals 10. Add the 8 over, you get 18. Divide by 6, so x equals 3. 0 to pair is 3, 4. Alright, so what's different about this one?
There's no like terms like
There's no like terms like.
that you can like cross out, like get rid of.
It's not like the last one because we couldn't just take one equation, multiply it by a number, and get them like, right? Or opposite like. You know, like we had been. Alright? Is there any rule that says you can't do both, though? No, there isn't. Okay? There's no rule that says you can't just multiply both equations. There's also no rule that says you can't multiply it by something completely different from your neighbor. There's also no rule that says you have to do x's or you have to do y's. So, theoretically speaking, there are 26 of you in this room right now. You all could have taken 26 different ways to do this problem and everybody still gets the same answer. As doing it, that's why I like elimination a lot more. Okay? Here's the differences. Substitution is a very methodical process. You solve for a variable, you substitute that expression in. You distribute, you combine like terms. You subtract your number over, you divide, you get your first answer, you take that, plug it back in, solve for the second. Every single time. That's your steps. No matter what the numbers are, that is your process. A little longer, but that's the way you do it. With elimination, it's a little shorter. Okay, it is shorter. That's why, and that's honestly, myself included, that's why most kids love elimination more than substitution. It's shorter, done. All right? You got to be able to see it though. That's the difference. You have to be able to see where you want to end up and know how to get there. All right? So, for this example here, you have 4x and 3x. You have 2y and 3y. All right? So what I would do when I see this, honestly, I go for my y's. Okay? I go for my y's just because the first number 2 and 3 go into is what? First number 4 and 3 go into is? And 6 is smaller than 12. That's why. Okay? That's the exact reason why I do it. Alright? Is there any rhyme or reason as to why I picked which one to be negative? No. Okay, so 2, I'm going to do this one by negative 3. This one by 2. Okay?
Oh, that
So negative 12x minus 6y equals negative 24. 6x plus 6y equals 18. Here's where elimination gets tough. You'll see the system. These numbers right here, they have to come from you. Okay? That's what I'm talking about with you have to know where you need to end up. Okay? It's kind of like the difference. Here's the difference, basically. It's like substitution, there's your path. You know the path, you walk down the path, you deal with the obstacles in the path. Elimination, you're kind of like, here's like a wooded area, and you got to chop your way through that path to make your own path. You got to see where you want to end up, okay? So you have to know that you need to multiply so that you have two numbers that add up to 0. So you have to see it over here in order to do that, all right? So that's why elimination can be considered to be tougher, because you have to know what you need to end up doing. Make sense? But once you do get it set up, it's a lot quicker. So we add them up, negative 6x equals, should be negative 6, right? So x equals 1. Take that in, either 1, I'm going to go top or bottom, I mean. So 3 times 1 plus 3y equals 9. And y equals 1 as well. So 1, 1. Oopsies. Alright, fix, hold on, right here. So 9 minus 3 gives you 6. So that should be 2. 1, 2, right? Everybody good now? Okay, my bad. So we have 5x minus 3y equals 6, 2x plus 5y equals negative 10. All right, now, last time I said the reason I did y's first was because the number was smaller, okay? The x is multiplied to what, 12, and the y's did to 6, I believe, okay? This one, I'm still going to do the y's, but for a different reason. And this is kind of, and if you pick the two reasons, this one's my go-to, okay? If I see this, I go for it. All right, what do I see? Dylan.
2 different signs. You got subtraction sign and you got.
Bingo. Yeah. All right. You got 1 plus, 1 minus. All right. If I see that, that's what I go for, no matter how big the number. Because what do I multiply by then?
2 positives.
2 positives, and hopefully, what does that cut down on? Not numbers, but negative. Your sign mistakes. If you multiply by positive numbers, typically your sign mistakes stay a lot less. All right, so if I see one sign and the other sign, that's what I go with. All right, so what's the first number 3 and 5 both go into then? 15, so that's what I go for, and then whatever it takes to get that done. All right, so 3 times what gives me 15? That'd be 5. The bottom one, 3. Okay, everybody good? Dylan?
But when you multiply it and you get the 5 equals on the 6 times 5 equals 30, and then the 3 times 10 equals negative 30. Don't they cancel out?
We're gonna get there. Okay. So 5 times 5 gives me 25x minus 15y equals 30. And then we get 6x plus 15y equals negative 30. All right, so everybody good there? All right, so 25 plus 6 gives me 31x. Negative 15y plus 15y gives you no y's. Equals 30 minus 30 gives me 0. So what's my answer? No, it's not. Okay? No, it's not. You still have a what? You still have a variable. So Federico, what does x equal? 0. Easiest question I'm going to ask you. What times 31 gives you 0? 0. Just because the constant on the end falls out doesn't mean it's infinite/none. It's when the variables go bye-bye, not the number itself. You can still divide by 31. 0 divided by 31 gives you 0. Okay? Don't, and I'll put that, I'm an evil son of a gun. I will put those everywhere. Okay? So be ready for it. Plug it back in, and we'll go top y, or bottom y naught. So 2 times 0 plus 5y equals negative 10, which gives you 5y equals negative 10, which gives you y equals negative 2. So 0, negative 2. A canoeist travels 4 miles downstream in 1 hour. The return trip takes the canoeist 1.5 hours. Find the rate of the boat in still water. All right, now this problem is special. All right, this needs some formula that you may not know yet. All right, does anybody know how you figure out distance?
Speed times time.
Close, but generalized speed. It's not called speed. It's called
Miles per hour.
no. It is. That's what we're finding. It's distance. Whoops, wrong button.
D equals
Times
times over
What's another word for speed? Lots of rate. Rate times time. All right, that's what you're looking for. Distance equals rate times time. For this problem, I'm going to write it just a little bit more pleasing for us and make it rate times time equals distance. Okay. Now, the reason this problem is special is because it's still a substitution elimination problem. Our two equations will still come from the words, but we'll need to put them in this format. Distance equals rate times time. Okay, so let's read the problem. A canoeist travels 4 miles downstream in 1 hour. The return trip takes the canoeist 1.5 hours. Find the rate of the boat in still water. Okay? Let's start with what's obvious and what we know. What's the distance?
4 miles.
4 miles. Okay? Now, how many equations did I say we're going to need? 2. One, explain where the 2 come from. Which 2 are the equations? The 2 equations come from what?
the return trip takes the canoeist and the rate of the boat.
Nope. Not quite.
How long it takes to travel now?
Nope. Yeah. Where are my 2 equations coming from? Okay.
Problem.
Very good. The problem. Alright. Now, we're going to pretend. Sorry for those of you that go home and watch the video because you won't get this. This is an in-class thing. Here's the river. Okay? What does a river do? It flows. Okay? It flows. So I'm going to say this river flows this way. Okay? This way. Alright? Now, the canoeist, here, I'm the canoeist. Hi. I'm sitting here in my canoe, and I'm going like this.
Why don't you have a helmet on?
I don't know, because I'm dangerous. I live dangerously. Alright? And I'm rowing. Alright? And one trip I go 4 miles which way?
Downstream.
Downstream.
That way.
And then I go 4 miles upstream. There's your 2 equations. One's downstream, one's upstream. Okay? Everybody see that? The canoeist is making 2 trips. One down, one up. Both times, his distance was what? 4 miles. So 4 there, and 4 there. Okay? Now, don't even worry about what the problem says. Just think about this with your heads and logically. What does a river do? It flows. So when I'm sitting here in my canoe and I'm rowing this way, what's helping me?
The flow.
The current.
The current, right? The flow of the current is helping me, right? Because it's pushing me along my way.
That way. It's
When I'm going this way, what am I fighting?
the current.
The current, because I'm going against it and it's pushing against me, so I gotta go harder. It takes you longer, okay? So, my question to you is this. Which direction am I going faster?
That way.
Downstream.
Downstream, right? So what's special about this? What about my rates? How many rates do I have? Two. One when I'm going down, one when I'm coming back up.
Right.
Okay? Here's where this setup of this problem gets a little weird. You have like 5 different variables going on. You have the 3 variables from your first formula. Rate times time equals distance. That's a general formula that's used everywhere. We haven't defined our 2 variables yet. Okay? There's 2 things we don't know. We don't know the rate of the canoeist. And we also don't know what? Linda? The rate of the current. We don't know the current rate either. Okay? So from there, we have 2 equations. Okay? When I'm going with the current, okay, when I'm going with the flow, does that help or hurt?
Help.
It helps. So what does the current rate do with my rate? Speeds it up, so put that as a mathematical operation. It adds to it. It adds to it. So you could say my rate for when I'm going downriver is my rate plus the rate of the river. Let me put that actually where it's supposed to go, not in the middle of the 2 equations. There. When I'm going back, does it help or hurt? Hurts. So x minus. Those parentheses goes right there. That's R. That's my rates. Okay? So my rate, we have my distance, which is the same. We have our rates when you're going downstream. It helps you when you're going upstream. The current hurts you. The only thing we're missing is what? Your time. Okay? How long did it take me to go downstream? 1 hour. How long did it take me to come back? Hour and a half, 1.5. Okay? So now let's clean these 2 equations up. I'm going to do something that starts with a D. Distribute. Okay? Let's make these look like they're actually equations we know what the heck to do with. So x plus y equals 4. 1.5x minus 1.5y equals 4. Okay? To save time for what I want you guys to do in class yet, I'm going to say finish this for homework.
Yeah.
All right, finish this up. Okay? I'll tell you right now, you should get answer. Notice how fast. Notice what you're trying to find. All they want you to find is the rate of the boat in still water. So you're just looking for which one, x or y. You just need x, okay? And x, when you solve this, should equal 3.33 forever miles per hour. Okay? Finish that one for homework. And whatever your timeline says, which is, should be page 360, 7 through 20. Okay?